All right. Hello, everyone. This is our database systems class CSCE 413 final project of COVID-19 analysis of the Midwest. I'm David Estrada, and I'll let our partners introduce themselves.
Nicholas Grisbrand.
Martin Hers.
All right. Just to give a little quick overview of this presentation, we'll first start off with our motivation and goals, go into a design overview, look at our data sources, and show a little bit of our data transformations, show a little preview of our MLPQ file, and then we'll go into our implementation and queries, and then finish off with some future work. All right, so to start off with the motivation and goals, it's been about 2 years now since the start of COVID-19, and it's still a very big problem today, so it's definitely important to stay informed with COVID data. So this database will provide basic COVID-19 data, such as new cases and deaths for the 12 Midwest states for each month from January 2021 to November 2021. This database will also be able to compare each Midwest state's COVID-19 data with each other and analyze information. It'll be able to see how state data, such as population density, obesity rate, and healthcare rank may impact a state's COVID-19 new cases and deaths. And finally, it would also give a risk classification of low, moderate, high, or very high for each of the states for a given month. All right, so looking at the design overview, there's 5 tables here. The main table being the map. It has attributes of state, which is the state's 2-letter abbreviation, and then it has X and Y constraints to build the map. Looking at one of the relationships the map table has to the COVID data table. The COVID data table has attributes of cases, state as well to reference back to the state from the map table, has deaths, month, which we have identified as a number, which represents the number of months since January 2021, and then also an ID attribute. Looking at another relationship to the map table, right below it, we have the has relationship with the state data. The state data table has, once again, the state attribute, which references back to the map table. It has population, healthcare rank, and obesity rate, and also population density attributes. Another relationship to the map table is the classified as relationship, which connects to the risk classification table. And this table also has the state attribute, which connects to the map table, also with the risk attribute, which is that low, moderate, high, or very high, and then the cases attribute. Finally, the last relationship above the map table is another report relationship to vaccine data table. And this vaccine data table has attributes of state, month, same month, similar to the COVID data table, the number of people fully vaxxed in a given state, ID, and then the fully vaxxed percentage for the state for that month.
So obviously we had to collect this data from somewhere. And one reliable site we use was through the CDC. So first, our COVID data was retrieved from the CDC website. We collected this from January 2020 to present, but we specifically focused on 2021. So we just did it from January 2021 to around now. And the next was some of our state information. The first was population data, which we retrieved from the census website along with healthcare rank, which is the only one not retrieved from a government site. And obesity data was also retrieved, but obesity data was a little different transformation wise, as that was mostly based on surveys the CDC had done. And the latest obesity data was from 2019. So we did the 2019 total obesity rate for each state. And then for vaccine data, we also retrieved that from the CDC site. And our COVID and the vaccine data was cumulative. So for March, it only have a certain amount, but by November, it would include months like March, April, June, July, and so on for our vaccine data, along with the fully vaxxed percent. We did fully vaxxed because because the data set had differences between fully vaxxed and partially vaxxed and vaccines administered that week. So we were focused on people that were fully vaxxed, either got 2 doses or 1 dose of certain types of vaccine. So we needed to transform this data, and one tool we use to our advantage was R, and specifically R was very useful for us in the sense that for the COVID cases and deaths data, we wanted to do it by month, and how the data was set up, it was day by day. So what we did was using the Lubridate and Tidyverse library, we were able to do some quick fixes such as rounding down all dates to the nearest month, because R is set up such as when you round, if you just say if you do the nearest month, it'll round up any date close. It would be like November 17th would round up to December. So we had to do floor date, make sure it goes to November. And then R classifies all as November 1st. And our data obviously spanned back from 2020, but we took out all data related to 2020 for our piece. And then we filtered for only Midwest states, because that's what we focused on. And this was also used for obesity data and vaccine data, as well as we were focused on grouping by month. Or in the case of obesity data, we only wanted the overall survey. There was a lot of mini surveys within the obesity data. We were focused on 2019 total rates for each state. And we were lucky to get that. And then we use Python scripts to then convert these CSV files into MLPQ format for CDC COVID-19 cases, state data, obesity data. And then for our states, we use the MATLAB script and transforming this data in order for us to help visualize the states. And here's an example of how our MLPQ file looks like. So our map is up by ID. We have the primary key for many of these is by states, just labeled a little different. It's like ID equals South Dakota would be for map, along with some coordinates that shape up the map. COVID data tells you, obviously, once again, state. It gives you the month, so that'd be February 2021, along how many cases were there that month, how many deaths were there that month. Then state data is useful because it obviously is state. Again, we have our population density, healthcare rank, and obesity rate. And then our classification one was also derived from CDC. And we did this based on each state. We did it based on per capita 100,000. So obviously a certain amount would be high, very high, moderate, low for our classifier. And our vaccine data was similar to COVID and state data. It would tell you how many people were fully vaccinated up to that point, along with percent in the state and the month.
All right, so here's just a simple decision tree based off our risk classification table. This is kind of how we would define each state as the low risk, moderate risk, high risk, or very high risk. And we kind of used the breakpoints that the CDC used as well. So we had to get the cases per 100,000 people. So that's why we have the 100,000 times cases there. And if that amount of cases is less than 50 times more than the population, then it'll be classified as low risk. And if the amount of cases is in between the set 50 times the population or 100 times the population, then it's moderate risk. And for high risk, it has to be in the range of 100 times the population or 500 times the population. And then for the very high risk, it has to be 500 times greater than 500 times population to be classified as very high risk. And so we took this data, we took this classification from CDC guidance and kind of applied it to the data that we grabbed in order to create a relation with the COVID data table to be able to classify different states and risks per each month throughout the year. And now we're going to go into more of the implementation and queries of our database. So the first query is a very simple, basic query. This is basically just using the risk classification table along with the COVID data table and using that to get the risk classification for Illinois on the month of June. So for this one, we would just have to select exactly what we wanted. So the state, the month, and then the risk level. And then we were taking it from those two tables, COVID data and risk class. And then basically, in order to make sure that we're getting the right risk classification, we have to make sure that the risk class cases and CD and the COVID data cases are equal to each other. And then we have to specify the specific month that we want, which would be 6 for June. And then we wanted to make sure we're getting only Illinois. So we set up both tables to Illinois, make sure we only get Illinois. And if we wanted to edit this to get all the risk classifications for all the states on the month of June, we would basically, all we would have to change is cd.state to equal rc.state, and that would return a whole list of states for the month of June and their risk. The next query we have is a simple aggregate function, SQL aggregate function. So we're using sum here, just get the sum of the deaths throughout the year for each state. So we just take this, take this data from the state and then take the deaths and just sum them together for each month. And then we group by the state. So each state only has one instance. And so we'll show you the total number of COVID-related deaths for, to that state for the whole entire year. And then, so we made a view called Midwest deaths, which is this pops up as. And so we can use this table to actually get some more interesting information. So using the Midwest deaths table, we can actually use that along with the state data table to get other information about the states, such as their population density, their healthcare rank, and their obesity rate, which we thought would be really interesting points for each state to compare and kind of see how it affects like the amount of deaths. And we did get some pretty interesting results from this, as population density really factors into the amount of deaths the state has. So the top 3 states with the most deaths are also in the top 3 for the highest population density as well. And then some of the states also with a lower healthcare rank and higher obesity rate tend to be on the higher end of COVID deaths as well. And so we thought that having this information and kind of comparing it together with the Midwest deaths would be interesting for people to see. And then using the Midwest deaths table, and just we were able to create a super simple bar graph with an MLPQ too, just using the y-axis will be the amount of deaths, and the x-axis is just a constant separating the just having a space between the bars so it's easier to read. And as you can see throughout the year, there's quite a big trend of, it starts off really high in January 2021, and it starts slowing down, and around like summertime, around like June, July, that area, when everything started opening back up because cases were low and the vaccines were widely available to everyone. And then you can start seeing it towards the end of the year pop back up when Delta variant became prevalent, and now we have the Omicron as well variant that we are dealing with. So you might see additional spikes if we keep track with this bar graph as it goes on. And then our last query, we did a union just to see if you had in October and November of 2021, which states had a high risk classification for both November and October. So we did this, and when we ran it, we only got it. Only one state had a high risk classification. Other states at this time in October and November were usually classified as a very high. In North Dakota was the only state that we got through this that was only classified as high. So that was interesting data to see as well. And we could also do this to include other 2 months together, or other variables that we want to find that for a relationship in the between states and the COVID data. And then so for possible future work, we add the rest of the states to view in the whole entire US. We only did the Midwest for this as it's prevalent to where we go to school in Nebraska and And so we thought Midwest would be prevalent, but adding the rest of the United States would also be interesting to compare the different regions of the United States, as well as compare the South to the East Coast or the West Coast, just be able to compare those and their existing state data too. We could also add in a prediction model for future months. So a lot of important COVID decisions are based off predictions, and using the data that we have, we could possibly make a prediction model using the past 2 months, like say October and November, or and use the COVID data that we have from there and kind of get a trend of what's going on, and use that data to kind of predict like how many deaths or how many cases a state may have for future months coming up. And then we could also add in specific data about different strains, especially since the Omicron variant is becoming prevalent now, and we're starting to see cases of that pop up. Each strain tends to act a little differently. Delta variant was definitely a lot more deadly than the original COVID strain, and each one responds differently to vaccines. So keeping track of that data and kind of seeing how it relates to the amount of cases and deaths per state would be interesting to add into this. And that is all we have for today. Thank you for listening.